Section 5.3, we're going to talk about inverse functions. So just like when we talked about natural log functions, the first part of it was, hey, do you remember everything that you need to remember? And so all of these guys should be things that you know already, that you've learned in other courses. The only really brand new thing is, of course, to find the derivative of an inverse function, but we need to make sure you understand inverse functions first. So I'm sure that you already know this and remember this, but any function can be represented by a set of ordered pairs where each x has only one y. So when we first learned about functions back in the day, we would always make one of these fun little mappings and say that this was in fact a function because each x only had one y. Now if 3 was connected to both 4 and 5, all of a sudden this is not a function anymore. So if we have a function with an inverse, then the inverse, and notice the way it's denoted, f negative 1, f to the negative 1x, which is the inverse of x, can be found essentially just by flipping the values around. So instead of the point 1 comma 3, this guy has the point 3 comma 1. Now graphically what that looks like, and we already kind of know this from when we looked at the natural log function and the exponential function, essentially what's going to happen is everything's going to get flipped over this line. And so something like that. So this is essentially what an inverse is all about, is you can flip the x with the y and the y with the x, which of course makes it reflect over the line y equals x. The domain of our first function, f, is equal to the range of the inverse and vice versa, which makes sense since all we're doing is flipping those values around. And again, functions that are inverses undo one another. So if I said my first function is y equals x plus 2, then my next function would be y equals x minus 2, because it would undo what was already done. And we'll talk later about, obviously this was a very elementary example, but we'll talk later about how to find the inverse of a function. Keep in mind that if you compose two functions that are inverses of one another, and again you could write it this way, f of f inverse of x or f inverse of f of x, either way you should end up back where you started. And again, that's just our way of saying, if I started, let's say my first value was 5. If I took 5 plus 2, I would get 7. Here it says now take 7 minus 2, and I end up back at 5. So notice nothing essentially happened. I did something and then I undid it. And so that's what it means when we have an inverse of a function, is that we can compose them and we can end up back where we started. Here are some important things to know about inverse functions. First, if g is the inverse function of f, then f is the inverse function of g. So it's not going to ever be where one is the inverse of the other, but not the other way around. The domain of the inverse is equal to the range of the original function and vice versa. A function does not necessarily have an inverse function, but when it does have an inverse function, there's only one of them. It's unique. So it's not going to be a set of inverse functions. It's just one function. And then, of course, as we already know, inverse functions are opposites of one another. So if you do something and then you do the inverse, then you're going to end up back with whatever value you started with. So before we remind ourselves exactly how to find an inverse function, let's just verify, if we have two functions, let's verify whether or not they are inverses of one another. So how do I do that? Well, I'm going to use the composition of functions. Remember, we said if f of g of x is equal to x and g of f of x is equal to x, then they're inverses. So this is showing the exact same thing, it's just showing the other notation. Remember that these two things are equivalent, they mean the exact same thing. So that's what I'm going to do, is I'm going to take f of the function g, so notice here I'm taking the whole function g and plugging it in. So I'm taking 1 divided by 1 plus x, and instead of x I've replaced it with g, the function g of x. And from here, my favorite saying, it's just algebra. So from here, I'm just trying to simplify. And the first thing I did was multiply by x over x because I don't like fractions within fractions. So that gave me something a lot easier to deal with because this guy canceled out. I got an x here. I got the denominator, or sorry, the numerator here. And then of course 1 times x is x. Then as we can see, x and minus x canceled, so I got x over 1, which is just x. Then I have to show that the other way also works. So now I'm finding g of f of x. So I'm taking this guy and plugging it in here. So I'm taking 1 minus f of x divided by f of x. And then again, this is just algebra. So why did I choose to multiply by 1 plus x over 1 plus x? Because I don't like fractions within fractions, so I wanted to get rid of the denominators. So again, just distributive property. That's 1 plus x. This guy canceled. This guy canceled, and I just got 1 as my denominator. So that leaves me with 1 plus x minus 1. Those guys canceled. That gave me x over 1, which is x. So I have verified they are inverses of one another. And it wouldn't be fair if I didn't give you a chance to practice one all by yourself. So feel free to press pause, try this question, and then press play to see how you did. Keep in mind this 3 seems a little bit higher than it should be. This guy is the cubed root. So press pause, try the question, and then we'll go through it together. Again, I'm going to go ahead and check f of g of x, so f of the function g. So I'm going to take f of x and replace x with the function of g of x. Then I'm just working through the math. This is a cubed root and a cubed, and so they went away. And so I just ended up with the fraction x plus 1 over 2. The 2's canceled. Then I had x plus 1 and then minus 1. Those canceled. That gave me x. And again, if I did the first step and the first step didn't work, I would stop. There's no point in checking the second one. But because the first one worked, I'm going to try the second, g of f of x. So I'm replacing x with 2x cubed minus 1 into this equation. And again, just working through the algebra. So I've got minus 1 plus 1 that canceled. I've got 2's that cancel. And now I've just got the cubed root of x cubed, which of course is x. And then again, this is just a great picture, a great visual to see exactly what an inverse would look like. Notice this is that line y equals x, and I could take the original function of f and flip it over the line y equals x, and I end up with my g function, and that's how I know that they are inverses of one another.